All right, let's go through 4 and 5. Now 4 and 5 are very similar. The catch is the formula. This is O2, this is O3. So in the first example, we only have 2 oxygens. In the next example, we have 3 oxygens. If you look in the periodic table, oxygen, doesn't matter how many you have, it's always in group 16, so that means it's got 6 valence electrons. So 2 times the 6 valence electrons is 12. So these 2 atoms have to divvy up 12 electrons so that they each end up with 8. Over here, these guys, still oxygen, still has 6 valence electrons, but there's 3 of them. 3 times 16, or 6 is 18. So they got to divvy up 18 electrons and share them all so that everybody gets 8. So the second step is to figure out which ones have an octet. So this picture here, A, we've got 2, 4, 6 plus 2 in the bonds. That's 8. Over here, 2, 4, 6 plus 2 in the bonds, that's 8. So it could be this one. The next one below it, 2, 4, 6, 8. That looks good. Over here, 2, 4, 6, 8. That looks good. So they both have 8. So that might be a possibility. The next example, so we got A and C as possibilities. The next one, 2, 4, 6, 8, 10. Remember, every double bond is really 4 plus 2, 2, 2. That's 10. 10 is more than an octet. Doesn't even matter what this one has. Right away, we know it can't be B. Down here, we have 2 plus a triple bond. Each triple bond is really 6. Remember, every line is 2. So if you've got 2, another 2, and another 2, that's a grand total of 6 being shared, going back and forth. So this is 2 plus 6, that's 8 for this oxygen, and this oxygen also has 8. So it could be D. So what we need to do now, since we have 3 possibilities for correct answers, is see which one matches the total 12. So let's count up here. 2, 2, 2, 2, 2, 2, 2. 2, 4, 6, 8, 10, 12, 14. That's too many. It needs to be 12. Let's look at C. 2, 2, 4, 2, 2. 2, 4, plus the 4 in the middle is 8, plus another 2, 9, 10, 11, 12. Hey, that matches. C is going to be our answer. And D would be wrong because we have 2, 6, 2. And if you add up 2, 6, 2, you only get 10. And 10 is not 12. So D is not it. So C is our answer. I believe model C correctly represents how the atoms in this molecule bond together. 12 electrons are present. This is our reasoning, our rationale. 12 electrons are present. And each atom gets the octet. Each atom has the 8, which is what we figured out in the beginning. That oxygen has 8, this oxygen has 8. And there's a double bond in between. Now let's look at O3. This is actually ozone. The common name for this is ozone. So, ozone has 3 oxygens. Remember, everybody needs 8. So if we don't have 8, it's wrong. This one's got 2, 4, 6 unshared plus 7, 8 in the bond. That's good. The center one has 8. 2, 4, 6, 8. That's good. Over here, 2 in the bond, 4, 6, 8. That one's good. They all have 8. So A could be it. But let's check others. So it could be A. Let's look at C. 2, 4, 6, 8. That oxygen looks good. The middle oxygen, though, has problems. The middle oxygen only has 4. 4 is wrong because it's not an octet. So right away, we know that C is incorrect. It's not C. B. Let's check out B. 2, 4, 6, 8. That oxygen looks good. The center oxygen looks great. It's got 2 double bonds on each side. 2, 4, 6, 8. That one looks good. The one on the right, 2, 4, 6, 8. That one looks good. Everybody's got 8 in B. It could be B. So we're going to make a little mark here showing that B is an option also. Now let's look at D. D has 2, 4, 6, 8. That's good. Middle one has 2, 4, 6, 8. That's good. And the end has 2, 4, 6, 8. That one looks good. So we have 3 possibilities for options here. Which one is it? Well, this is where we have to go look at what did we start with. We started with 18. So which one has 18? So just count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. It's not A. Let's look at B. 2, 4, 6, 8, 10, 12, 14, 16. 16 is not 18. So B is wrong. We think it's D because it's the only one left, but let's just check. 2, 4, 6, 8, 10, 12, 14, 16, 18. 18 matches. So it is D. We found our winner. D. We know D has 18 electrons, and everybody had the octet. There was a double bond here and a single bond here, and all those extra electrons gave everybody the octet. All right, let's look at pH3 and then SO3. pH3. There's 1 phosphorus because the formula gives us an imaginary 1, and there's 3 hydrogens. Check the periodic table. Here's phosphorus in group 15, so it's going to have 5 valence. And remember, hydrogen we learned has 1, simplest little guy. So 1 times 5 is 5, 3 times 1 is 3. Add them up to get the grand total, you get 8. So they have to share 8 electrons, all 4 atoms. A is wrong. Little hydrogen, remember we talked about hydrogen only needing 2. It only needs a single bond. If there's anything but a single bond, it's automatically a sign that it's wrong. This hydrogen has way too many electrons. Wrong. This hydrogen over here in B has way too many electrons. Wrong. So C and D could be correct. Let's look a little more. This hydrogen has 2. That's good. This one has 2. That one has 2. Over here, each hydrogen has 2. All they need is that single bond, those 2 electrons zipping back and forth. So now let's focus on our center atom. This phosphorus has 2, 4, 6, 8. This phosphorus only has 6. It only has shared. It doesn't have any unshared. This one has these little 2 unshared electrons up there, which together with the 3 bonds adds up to 8. So C is correct. D is wrong. D is wrong because P doesn't have enough. So we finished. We know it's C. We know that there's 8 electrons. There's 2 here, 2 here, 2 here, plus 2 up there. So that's 8. And everybody has an octet. Hydrogens only need 2, and phosphorus needs 8. And by connecting this way, single bonds and all those extra electrons on top, that adds up to our octet. All right, over here we again have 4 atoms. 1 of these sulfurs and 3 oxygens. We know sulfur and oxygen are both. Here's sulfur and oxygen. They're both in group 16, so they both have 6. S and O both have 6 valence. So 1 times 6 is 6, 3 times 6 is 18, 6 plus 18 is 24. They got to divvy up 24 electrons. Let's see if we can rule anybody out. This has 8. Oxygen down here is 8. This oxygen has 8, but poor little sulfur only has 6. It needs an octet. Wrong. Let's look at down here. 2, 4, 6, 8. Oxygen's good. Sulfur in the middle has 8. That's good. Oxygen down here has 8. Oxygen over here has 8. This is looking pretty good. It might be C. So we're going to make a little note. Maybe it is C. Let's look at B. Right away, that's nuts. 2, 4, 6, 8, 10. Boom, it's not an octet, it's wrong. Down here, 2, 4, 6, 8, that oxygen looks good. Sulfur in the middle looks good. It's got 2 of its own plus 6 that it shares. 2 plus 6 is 8. We got 8. We got 8. Everybody's looking great with 8. So we have 2 possibilities. It's either C or D. So we've got to match up the total number of electrons to what we figured out in step 1. Let's just start counting. We got 2, another 2, 4 in the bonds, 2, 2, 2, 2. You get the idea. You're counting a lot by 2s when you do this. So if you count all of those up, you'll end up with 24. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. This has 24. That looks like our winner because that matches, but let's just check D. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. That's why D is wrong. So C is our correct model. It has 24 electrons there, and everybody has the octet. There's a double bond between those two, single bond there, and a single bond down there. Everybody has the 8. And we're good.